So we're starting our probability unit. Whenever we're talking about probability, we're really just talking about the chance that something happens, or the probability is how likely it is for an event to occur. So the chance that something happens is always decided by one simple ratio. That's the favorable outcomes divided by the total possible outcomes. So you can write this as a fraction, you can change it into a decimal, or you can change it into a percent. You're going to see probabilities written in all three different ways. Either way, it represents the chance out of, let's say, a percent chance out of 100, or a decimal chance from 0 to 1, or a fraction from still 0 to 1, representing how likely it is that something happens. All right, before we get into actually describing probability, I just want to go into this ratio a little bit more. Favorable outcomes, it's not necessarily a good or bad thing, it's just the desired outcome or desired result, really whatever we're talking about in the question. And the total outcomes is anything that could possibly happen, all possible results of an experiment. When I say an experiment, we could be talking about a spinner being spun, a die being rolled, a coin being flipped. It doesn't have to be like a science experiment. It's really just talking about any sort of event that's happening with more than one possible result. So when I talk about a desired result, I'm talking about specifically what's the question talking about. So one example is rolling a 6 on a die. There is 1 6 on a die. The chance of rolling a 6 on a die, at least the number of favorable outcomes there, is 1. It's 1 out of the total possible outcomes. If we talk about the chance of rolling an even number, well, a die has 1, 2, 3, 4, 5, and 6, so 2, 4, and 6 are even numbers. So there are 3 possible chances of rolling an even number. There are 3 favorable outcomes in this case. If I talk about rolling a number greater than 4, a number greater than 4, it includes just 5 and 6. So there's 2 possible outcomes, 2 possible favorable outcomes when we talk about rolling a number greater than 4. Those are just 3 different examples. And in that experiment, there are 6 possible outcomes. When you roll a die, you can get a 1 through 6. That's 6 possible different outcomes. So the chance of rolling a 6 on a die is 1 out of 6. The chance of rolling an even number on a die is 3 out of 6. The chance of rolling a number greater than 4 is 2 out of 6. It's the favorable outcomes over the total possible outcomes. So that's what we're going to practice with here. We're going to find the probability of each event and then plot each of those points on the number line, and we'll write the letter above each plotted point. Okay, actually before we even get into that, I just want to talk about the scope of probability in general. Probabilities always range from 0, which means the actual event is impossible, to a possibility of 1, which means it's absolutely certain. So there's a whole range in between here. It's always going to go between 0 and 1. It can't be negative. It can't be bigger than 1. It can't say that it's more than certain to happen. It can either be certain, impossible, or somewhere in between. 50% or 0.5 or 1/2 means it's equally likely to happen and not happen. So like flipping a coin, it's an equal chance of getting heads versus a tails. That's a 1/2 chance of getting a heads, 1/2 chance of getting a tails. The probability that tomorrow is the beginning of summer break, that's a 0 possibility. That will not happen. The probability that I will check your homework during our next class is 100%, or 1. It is certain to happen. It will definitely happen. So those are all the possible numbers for a probability. So on letter A, the probability of rolling a 5 on a 6-sided die. There is 1 5 on a 6-sided die. There's 1 favorable outcome. There's not 5, there's 1 of them. There's 1 5 on the die, there's 6 sides, it's a 1 out of 6 chance that that happens. It's really tough for me to picture a fraction on here, so I'm going to change that into a decimal. I'm changing that to 0.16 repeated. I know that this decimal is 0.25. I know that this one is 0.50. I know that 3/4 is 0.75. So when I think about 0.16 repeated, 0.1, really just looking at the 1, that's smaller than a 2. So A will go somewhere in between here, a little bit closer to 0.25 than it is to 0. All right, find the probability of spinning a 3 on a spinner numbered 1 through 25. Okay, so there is 1 3 in that range. There's still just 1 favorable outcome there. There's 1 3, but there's 25 options now, 25 possible different outcomes. It can be any number 1 through 25, so it's a 1 in 25 chance, or a 0.04 chance, or 4% chance. Either way, that is a very small decimal. That's going to be very close to 0. We're really just comparing this 0 compared to that 2. That's smaller, so it's somewhere in between here, and it's closer to 0 than our A was. All right, for letter C, out of Liberty's 1,109 students, 1,012 have first names less than 9 letters. Find the probability of randomly selecting a student with less than 9 letters in their first name. All right, so our desired outcome here, the favorable outcome, is picking a student with less than 9 letters in their name. We have that number here, that's 1,012. The total is our whole population at Liberty, 1,109, and that as a decimal is about 91.3%, 0.913. That's pretty close to 1. It's definitely bigger than 0.75. That's a 7 versus a 9. It's going to be pretty close to 1 there. For letter D, a bag contains 4 red starbursts and 3 pink starbursts. Find the probability of randomly picking a red starburst. So the desired result is the 4 red ones. The total is all of the starbursts that we have. That's 7 total ones. That's 4 plus 3. That tells us all of the pink and red together. 4 out of 7 is about 57%, 0.571. So letter D is bigger than 0.5. It's 0.5 and then a little bit extra, 0.57. But it's not quite bigger than 0.75. So it's somewhere in between there, probably closer to 0.50. So like I said on the front, probabilities can be seen in a few different ways. We can see it as a fraction, as a decimal, and as a percent. Fraction, decimal, and percent. They all mean the same thing, just like when we're comparing and ordering numbers. We can see numbers as fractions, decimals, and percents. They all really mean the same thing. The important thing is that it's always between 0 and 1, and 1 means it's dead certain to happen. 0 means it's absolutely not going to happen. Okay, and again, we're always looking at favorable outcomes over the total number of outcomes. So, when we're trying to find the probability of spinning a 6 on this spinner, we have 8 possible options. That's our total number of outcomes. And there's just one 6 on here, so it's 1 out of 8. We're trying to write this as a fraction, so we're done with that one. 1 out of 8. We're writing the next one as a decimal. So we're going to try to find the probability of spinning a number greater than 5. So we have numbers greater than 5. That's 6, 7, and 8. That's 3 options. Out of still a total of 8 on the spinner. That's 3 divided by 8, or 0.375. The last one we're going to write as a percent. We're trying to find the probability of spinning a 1 or an 8. So the favorable outcomes there are getting a 1 or an 8. 1 or an 8 is 2 possible outcomes. Out of our total, still 8, that's going to change to a decimal as 0.25. 2 divided by 8 is 0.25, and that's 25%. So there's a 25% chance that we land on one of those 2. Alright, so these next 3 problems are really just asking us questions about these pie charts. These are showing the source of fish imported to the U.S., going from 1998 to 1992 to 2000. This is saying that in the first year, 60% of the fish were from Canada, 13% were from China, and 27% came from some other country. Alright, so looking at that first question, if we picked a random imported fish in 1988, what's the probability that the fish would be from Canada? So we're really just looking at this graph. The chance that it comes from Canada is this 60%. There's a 60% chance that it comes from Canada. On the next one, if we picked a random imported fish in the year 2000 in that graph, what is the probability that the fish would be from Canada or China? So we're going to put those 2 together. The chance that it's from Canada or China is these 2 put together. 30 plus 28 is 58. On that last one, if we picked a random imported fish, which year would we have the greatest chance to pick a fish from somewhere other than Canada or China? So we're looking for which one has the biggest other category. That's definitely 1992. It's 46% versus 42%. versus a 27% chance. So in 1992 was the best chance to get a fish from somewhere other than China.